Welcome back. In the previous videos, we looked at how we can synthesize an aldehyde or a ketone. For aldehyde, we only looked at one method, with this oxidation of a primary alcohol. Whereas for a ketone, we looked at a plethora of methods. Any of those methods could be on a test, homework, or a quiz. Now, here we are going to look into reactions that say once you have an aldehyde and a ketone, what can you do with it? All right, so this is the first one. Oxidation, okay? Whenever you oxidize an aldehyde, you produce an acid. So let me write that down. Let me make sure I have the right color. All right, I do. Okay, so whenever you oxidize an acid, or aldehyde, sorry, aldehyde, when oxidized, okay, I'm going to write OX for oxidized, produces an acid, okay? A ketone, when oxidized, there is no reaction. So I guess that is just as easy as it gets. So no reaction. So if you remember again from our functional group naming in the previous material, aldehydes are indicated by RC double bond OH, and acids are indicated by RC double bond OH, right? So when you oxidize an aldehyde, you get an acid, whereas when you oxidize a ketone, there's no reaction. So this is an oxidizing agent. As I said, anything with chromium, okay, is oxidizing, okay? That's one way to remember it, because chromium is a powerful oxidizing agent. Okay, derivatives of chromium is what I meant to say. So here we have an aldehyde because the C double bond OH is at the very end. So this is an aldehyde. All you have to do is it becomes an acid. You don't change the number of carbons, okay? You retain the same number of carbons. So here we have 1, 2, 3. This is not for numbering, just for count. We have 4, so we can only have a 4-carbon acid. So all you have to do is replace the H with an OH. It's just that simple. Now we have an acid. So we went from an aldehyde to an acid. Here we have a ketone because this is a methyl group, so there is no reaction. It's just that simple. When you go from an aldehyde to an acid, this is an acid. You cannot change the number of carbons. The number of carbons has to stay the same. Here we have 4 carbons. Here also we have 4 carbons. Okay, so the number of carbons has to stay the same. Okay, now I would like to, since we talked about oxidation, there's 2 different types of reduction. However, I do want to talk about one of them in this video because, you know, just to contrast oxidation and reduction, and I'll talk about the other reduction in a separate video. All right, so these are the 2 common. So anytime you see, I think this was in Chem 330 as well, anytime you see lithium aluminum hydride, sodium borohydride, these are excellent reducing agents. Means they supply hydrogens to an existing reactant, okay? They supply hydrogens. So if you start with an aldehyde or ketone, the product would kind of look the same, okay? What are we going to do? We are going to add, draw everything the same way, okay, except the double bond O. We are going to add a hydrogen and then replace the O with OH. That's what I meant by a reducing agent, supplying hydrogens. Again, there's a reason why I don't want to go into the mechanism, because when we have every reaction with a mechanism, the video is going to be extremely long, and you may not be able to remember every one of them either. It's just practically not possible to remember every single mechanism, okay? So all I have done here is replace the C double bond O, okay, with CH H and OH. Basically, that's what a reducing agent does, is you replace the double bond O with an OH and an H. So an aldehyde always results in a primary alcohol. Did you see that? We have a primary alcohol now. This carbon containing the alcohol group, which is the OH, also contains two hydrogens. So when all aldehydes are reduced, it produces a primary alcohol. Whereas when we do the same thing to a ketone, which is the one below, as I said, you draw everything the same way and replace the C double bond O with the C bond H and OH, right? Same thing as above, but this time you see it results in a secondary alcohol. So that's the classic thing I want you to take away from it, is let's write it in a different color. The drive home message is when aldehydes are reduced, okay, aldehyde when reduced produces a primary alcohol, and a ketone when reduced would produce a secondary alcohol. Okay. All right. I got one more reduction video, but I'm going to stop this here because of keeping the video less than 10 minutes long. So I'll see you back with another video on reduction of aldehydes and ketones. Stay tuned.